Live. Okay, so question 3. The symbol for the true population proportion is which of the following?
I've been really good. How are you? Yeah, just Mr. Clearwell.
Okay,
Is
hold
it
on.
tilde,
Are you
P
doing
hat,
classes?
or B?
Yeah. What are you doing?
I believe that is P, correct?
Symbol for true population
So-
proportion.
So there's 300.
Yes.
340.
Okay, so that's B.
Last class.
I think it's number
No,
3,
that's
right?
the third one. Yeah.
I'll wait for it.
Alright.
So the sum for the true population, yeah, it's B.
Yeah. Well, Robert's online. I can't.
Okay.
Go ahead and
next.
just read the information bullet. For the next 2 questions, suppose n equals 100, p equals 0.25, and p hat equals 0.10.
Yeah. We're still gonna be here through the summer, but I'm hoping we're gonna get that.
Okay.
And just
Requirements for
and
Control.
Okay, no, not really yet. But
So with this, how do you determine what your x is supposed to be for the one proportion sample test in the Excel thing?
Oh
I ended up reverse engineering things and got 10, but how did you guys go about it?
So the confidence interval is the sample size multiplied by p hat greater than or equal to 10, and it would be because 10 multiplied by 0.1 is 10, or 100 multiplied by 0.1 is 10. So I would say true on the confidence interval, and then the requirements for conducting a hypothesis test is the sample size multiplied by the p-value. So that needs to be greater than or equal to 10.
And which it is, right? So it'd be the 100 times
1
1.1,
minus
so it'd be
is 0.75 multiplied by, yeah, so I would say true on both questions 4 and 5.
pull that up.
Good.
Textbook as well.
We all agree on that?
Yeah.
Yes.
Yeah, I saw that in the videos as well.
Okay, question 6. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on the trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find p hat, the point estimate of the proportion of the first-degree murder defendants who are found guilty in the state. That, let's see.
Okay. So
0.750.
n is 60. Come on. You have 0.75.
Yes.
You got that by dividing 45 by 60, right?
So I did, but I'm using the one sample z-test for proportion, and I just put in x. X is the observation for the sample size n. And if you put that in the inputs, it'll spit out the p hat information. And you just put it in the spot.
Yeah, my Excel's locked down again, so lovely. But as long as I also got the same answer doing it manually, I'm just fine with that. Tim, you okay with that?
Yeah, I'm okay with that as well. So that was just it was the 45 divided by the
60.
the 60 there.
Mm,
Oh, really? Is it
Okay.
like a little Sin City on there? Oh boy.
All right, I'll read the next guy. Create a 95% confidence interval for the true proportion of first-degree murder trials in the state the verdict is guilty. Input your answers for margin of error, lower bound and upper bound.
It should be okay. And,
I haven't.
Okay, so this would just plug this guy in, right?
Married.
So they
Yeah,
give
but
you
what is a margin of error at on this sheet?
So margin of error. Well, no.
set the confidence interval, the upper bound minus the lower bound divided by 2.
Need the answer too.
That's how we found it. I believe in the other.
Yes, that's right. Yes, right.
Okay, cool.
So in this, under heading 3, sample size calculations, it gives the formula for the margin of error as the z-score multiplied by the root of p multiplied by 1 minus p over the sample size. So it's essentially z-score multiplied by standard deviation. So what's the z-score for
95 is 1.96.
1.96?
I'm sorry. So where are we plugging in the z-score on this?
How did they get away with that without getting arrested?
Z-score is multiplied by the root of p multiplied by parentheses 1 minus p parentheses divided by sample size. I guess the issue with the margin of error is that we don't have the p-value.
Let's see, but they give us 45 or 60, which is the sample size, right? So that's the n.
Small.
But wouldn't P be,
No,
oh, come on.
I can never do that.
Oh, they have a different formula if you don't have P.
Oh, which one was that?
Sorry, I misread it. It's to sulfur in.
Yeah, so
That's for dissolve. Yeah.
I think that those formulas, at least the way that it's being described, is for finding the number of samples to obtain a specific margin of error. So I think, I don't know, I think we just give Tim's suggestion a try, see if we can use the confidence intervals to.
Yeah, I think that'd be the way to do it.
So for number 7, I got 0.11.
That's for the, sorry, your margin of error was 0.11?
Yeah, but
And I couldn't hear what they were saying.
Okay,
Is it just
my confidence interval is 0.640 on the
yeah, that's what I got.
and 0.86.
And then
Do you know
0.860.
Yeah.
like one strand is like 10 or 20?
Cool, that's what I got.
So,
Okay, works for me. So
I mean, that
point
makes
one,
sense. That's,
correct?
Yeah, 0.11.
Mhm.
0.640, 0.860.
Sorry, what's the lower bound again?
0.640.
And 0.680.
Hold on. 0.860. Yep.
0.680 or 860?
860.
860, okay. Just transpose those. So, question 10, if you increase the sample size from 60 to 80, what do you expect to happen with the confidence interval? Will that decrease?
It'll
No,
increase, right? Because
Okay.
the sample size, as that goes higher, I'm pretty sure the confidence interval goes up, or the width of the confidence interval.
Decrease
So-
because you're divided by a larger number before you take the square root, so it's going to decrease.
Yeah,
Okay,
it
yeah,
does.
that makes sense. Okay, so I'll decrease, and then number 11. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest N can be, and both requirements still be met?
So it's 0.5.
Is 1/2.
So for the first value, it's 20. And then it would be the same for both, is 1 minus 0.5 be 0.5 multiplied by n. So essentially the same number for np is less than or equal to 10, and n multiplied by 1 minus p less than or equal to 10.
So it is 2411.
Yeah, are you guys seeing the same thing?
See, okay. So so T is
Hi, sorry about that. The internet cut out and then just forced me off.
I think we're still working on question 11.
Okay. Okay, so I haven't missed too much, right? Or are you guys just discussing it or looking?
So I got 20 for both of the hypothesis test requirements.
Okay, and how did you find that? How did you find the 20?
So hypothesis test requirements are n multiplied by p is less or greater than or equal to 10, and
All right.
n multiplied by 1 minus p is greater than or equal to 10. So I just plugged in 0.5 for the p-value, n multiplied by 0.5.
Wait, you said 0.5 times 0.5?
Right, because it says suppose p is equal to 1/2. So we just take the
Oh,
decimal,
okay, right.
divide that by 10, that gives us 20. And in the second equation, it's 1 minus 0.5, which is 0.5. So it's the same thing, 10 divided by 0.5, which is 20. So for question 11, I got 20.
okay. So I see how you get the 10 divided by the 0.5, which gives you the 20. How did you calculate the second one to get the 10? The n minus 1 minus p. So that's
So p-value is 0.5. So
okay.
you take 1. So obviously, order of operations tells us 1 minus 0.5 first, which gives us the same equation in effect as the first one, because 1 minus 0.5 is 0.5. So at that point, it just becomes the two equations map.
Okay.
Okay, that makes sense. So to determine what the lowest n can be, you would just take the 10 divided by the p-value.
Mm-hmm.
Okay. So that's for 11.
Right.
So
Okay. And we
12
need. Okay. I got things set up now.
Sorry, what was that?
I have everything set out now, so it'll calculate it correctly.
Okay. So 12 is a bit different because it's going to give us different values. So the first equation, n is equal to 100 samples. And in the second equation, n is equal to 11.1. So if it's 11.1, would we round up? Because we need it to be equal to or greater than 10.
Mm-hmm.
Well,
You can't have 0.1 of a sample.
oh yes, you need to round up, so it becomes
12.
12 for that one.
But then if you only take 12 samples, then you wouldn't satisfy the first requirement. So would it be 100 samples?
It's got to be the minimum of 100.
Yeah, that's kind of what I'm thinking too.
Okay.
Okay, I'll take this one. For the water quality study in the reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis test using significance level alpha is equal to 0.5, 0.05, with the following hypotheses. Null is equal to 0.6, alternative P is less than 0.6. They collect new data, and this time N is equal to 80 and X is equal to 38. Indicate good health. So first question, the conditions for conducting a hypothesis test are satisfied, true or false? I got true.
N times p hat is greater than or equal to 10. So it'd be
So, and it also, if you input X and N in the one sample z-test proportion Excel data spreadsheet, it'll give you those requirements as well.
okay. Yeah, so then that'd be, they give you, yeah, the p hat is 0.475.
Yep.
Right? Times the N, which is 80. That's, yeah, and that's greater than
0.475 for p hat for 14, correct?
Correct.
No wonder why I was getting confused on some of those ones. I was looking at the 2 proportions instead of the 1 proportions for some of the calculations.
Oh, yeah. That'll do it. That'll change it.
Okay, test statistic. That's, oh boy. That's not our p-value. Oh, it's our z-test.
Yeah, so essentially you just set it up like you would the one sample T. Because our null hypothesis is 0.6 and it's a less than test. So our p-value, or the test statistic, excuse me, is negative 2.282.
That's what I have as well.
We got something different. So the type of test is less than.
Mhm.
And we have to change the null hypothesis to 0.6, right? You said.
Mhm.
Okay, so negative 2.28 or 2.82.
Negative 2.282. Yep.
282, right? Okay, got it. 282. Okay. All right. P-value 0.011. And the decision is, so it's less than the p-value is less than the alpha. So that's
Reject the null hypothesis, correct?
yes.
I believe so.
Okay, and I would say there is insufficient evidence to conclude that water quality in the area has not decreased. So the top one.
So if we rejected the null, we're accepting the alternative hypothesis. So the alternative is that it has decreased.
Well, yes, but you can't definitively say that the alternative hypothesis is correct. You can only say that the null hypothesis is incorrect.
Mm-hmm.
Okay.
So the null hypothesis is that their water
Has
in the
not
area
decreased.
has not decreased.
So you
Okay.
say there's insufficient evidence to conclude that the water quality in the area has not decreased.
Right. Okay. That makes sense to me. All right. Should I submit tonight?
Sounds good to me.
All right. Okay, we got number 6 wrong. And the last one wrong,
No.
number 18. So number 6, let me just double check the answers. That did we all put 0.075?
As 0.750.
No, 750. Okay, I just put that in wrong, I guess. 0.750.
Yeah.
Okay. All right, and then 18 is wrong. I had the first one down.
So you have the top one down. Insufficient evidence. Okay.
So
You
I
think
would
it's the
say-
last one?
yeah, because if we're rejecting the null hypothesis, then by definition, we would accept the alternative hypothesis, at least for the particular study, which I don't know. These have always been a bit confusing to me, but
I think you're right, because you never accept the null hypothesis, but when you
right.
fail to accept it, you accept the alternative hypothesis.
No. I'll go ahead and try it and just see what happens with the last one.
Okay.
Yeah, these ones have always confused me. So,
Yeah, they're very wordy.
yep, the last one is correct.
Okay.
That's 100%.
All right. Cool.
I'm gonna go ahead and stop the broadcast.
Awesome.